We're so excited to get started with tonight's program. Thank you so very much for joining us. My name is Celine. I will be your audience host tonight. What that means is that my video will stay muted while Dr. Chun and Dr. Raynolds have the limelight, the spotlight. But I will be moderating questions in the end. So as you're watching the presentation, go ahead and type up those questions in the chat. You might not be able to see what everybody else is saying, but we will, and we'll pull some questions, as many questions as we can at the end of tonight's program. I will go ahead and introduce Dr. Kachun. Dr. Kachun, you have the floor.
Hello, everyone. Before we begin, I want to acknowledge that we are in Denver and at the Denver Museum of Nation Science. We're on land that today is the traditional homelands of the Cheyenne and the Arapaho. We're the original stewards of this land, and we also like to acknowledge other indigenous tribes and nations that have made Colorado home. So with that, I want to welcome everyone to Digital Earth. For those of you who are new to this program, the idea behind Digital Earth is to explore our planet Earth from an astronaut or from a space-bound perspective. And so to see it as astronauts and our satellites do, and to explore the geography and history and geology and other scientific aspects of the Earth. This is a program that we've been doing for over 10 years, normally in the planetarium, but given what's been happening, we have switched over to live online programs, and hopefully we'll be able to return to the planetarium again, but until we do so, and the planetarium is a great experience because you'll be able to see all these visualizations immersively, but until then, we will continue to bring this experience into your home. One of the terrific things about this program is that we are seeing a simulation of the Earth, and we're seeing data that's been provided from satellites from NASA as well as other organizations. And so we've seen real data presented to you. And the software that we're using tonight is called OpenSpace. It's a project that originated from our friends at the American Museum of Natural History in New York. And it's a project that's also funded by NASA. And as a result, part of our agreement and commitment to working on this project is we also want to hear from you, the viewers, as far as your opinion about how this program has gone. And so at the end, for the Q&A, we will be posting a link for a SurveyMonkey evaluation, and we hope that you will participate in that survey and tell us what you think about this program. And for the first 30 participants that click and submit their survey, you'll also be getting a free NASA logo sticker. All right, so with that, this program is live flown, meaning I will actually be flying through the simulation. And with that, I'm going to turn it over to my colleague and friend, Dr. Bob Raynolds, who is a research associate and a geologist at the Denver Museum of Nature and Science. Bob.
No, thank you, Kachun, and thank you, Celine, and welcome everybody to Digital Earth. And we do these programs sort of on a one-off basis, meaning Kachun and I have been choreographing this for quite some time, but it's always a little bit of an experiment, and we are never quite sure exactly how things are going to work out. So we will be doing this. Everything's happening live, and we're moving across the Earth, and we're moving through a variety of images sort of in real time. So we beg your understanding if things get a little bit tangled here or there. But our goal this evening is to go around the world twice, and we've never done this before. It's an ambitious geography that we're hoping to cover tonight, and we will be looking at deserts from stem to stern, really, across the country and across the world. And it's going to cause a lot of flying. So Kachun's going to be at the controls. We're going to be moving across a lot of territory. and bear with us. So but you will see us go around the world twice. We plan to end up in Colorado, end up right back at home. So we'll see if we can make this all work. But let's get started. Our program is really in three parts tonight. The first little part is about the physics of why deserts are where they are, a little bit of a discussion about the global circulation patterns. The second part is a quick tour of some of the better known deserts, sort of the biggest, the highest, the lowest, things like that. And then the third part, which is the most important part, certainly from my point of view, is how are we adapting to living in deserts as a species, as humans? What's going on with our lifestyle near and in deserts, and what's likely to be happening in the near future as we continue to face challenges with the growing population and people living on the fringes and in fact in the midst of deserts. So that's a three-part story, and we'll try to hold it together. But let's get started, Chun, with our visualization of the global circulation patterns. And here what we're going to show you is an artistic rendering of the Earth rotating, and the atmosphere is really a thin veneer on top of the planet. As you know, it's only, it's not very many miles thick. If you get 4 or 5 miles up into the air, you're running out of oxygen. But the situation is that the Earth, of course, is a spinning sphere, and the sun is illuminating the equatorial zones, the tropical zones, more brightly and more intensely than the higher latitudes. And the net effect is that there's higher temperatures in the equatorial zones. And because the atmosphere is a fluid, it responds to this heating, and it expands and moves away from the zone of heating towards a zone that's cooler. And you get a broadly spoken, a circulation pattern. We call them the Hadley cells. They're the tropical convergence and the circulation pattern right around the tropics. And the net effect is that you get air that's circulating that rises at the equator, and then it moves towards the poles, and it drops down and falls. It's been cooled and dried out, and as it descends, it warms up and is very dry, and you tend to get deserts at those zones at about 30 degrees north and 30 degrees south latitude that are controlled by this global circulation pattern. The red patterns on the spinning sphere are the deserts. You'll see the Australian desert at 30 degrees south. You'll see the Asian deserts and the Sahara deserts at about 30 degrees north. And you'll see the same patterns we come across into the Americas. And so this is the first order reason why there are deserts. And then the other thing that's very important is the topography of the Earth is not uniform. And we'll mention several times the effect of rain shadows. So the combination of the global circulation patterns and rain shadows are two of the largest, most significant physical parameters defining the distribution of deserts on the globe. So now let's go on. We might look at the PowerPoints here, Chun, just to get that part out of the way. And we've got 4 slides here. The first one just reminds us that the population of the world has grown quickly in the last few centuries. And we now live in a world with a population in excess of 7 billion, heading for perhaps 10. We're not quite sure how high it's going to go. And these people are encroaching all the landscapes of the world. The next slide will just show this is what's called the Keeling Curve, named after Ralph Keeling. And you'll see the systematic rise in the carbon dioxide in the atmosphere. It used to be that it would range between about 180 and 280 parts per million. And you can see now it's up somewhere in the vicinity of 415 or so parts per million. And it's climbing systematically as a function of the combustion, largely of fossil fuels. The next slide will just show the fact that because of the blanket provided by the greenhouse phenomenon, we're getting more energy in than is leaving the planet. We're at a time of disequilibrium. And the net effect of that, shown in the next slide, is the world is getting warmer. And there's lots of ways of measuring this. Many of you will have experienced it in your own experience. We've got data sets here in Colorado where we've actually measured temperature through time, and we can see the temperature increasing in places even like Rocky Mountain National Park, where there's no it's not an urban area, or it's not affected by urban heat islands or anything like that. So we can see things in getting warmer. Growing seasons are getting longer. My sister who lives in Fairbanks, Alaska, reports that she's got a week more of growing season on the front and the back of her growing season than she had when she moved there 25 or 30 years ago. So things are changing, and we live in a time of aridification. The areas that are warm are getting warmer, areas that are dry are getting drier. So the desert story comes right into this issue of a changing climate and a changing environment. So let's now proceed to look at the Sahara Desert. We are going to show you these views on open space, and the Sahara is the largest desert in the world, and we might parenthetically mention that there's not much precipitation in Antarctica and in parts of the northern latitudes. So technically a desert is defined as an area where there's less than 10 inches of rainfall a year. That number is a little bit flexible, but there are dry areas that are in polar regions, but we're going to be talking about the hot deserts. And here, as you look at the Sahara, we're just sort of coming in, and you'll see sort of a fuzzy character to it, and you'll see some fuzziness extending out into the Atlantic Ocean there on the left-hand side of your screen, and that's actually dust blowing off the Sahara across the Atlantic, and that's a phenomenon that has been observed repeatedly, and we've done deep sea coring and studies of the seafloor, and we see the dust of the Sahara Desert spread across the North and Central Atlantic, extending as far as into the Caribbean. It's an amazing phenomenon. But we're going to, in our first tour of the world here, we're going to sort of sashay our way across the Sahara Desert, and we'll probably jump close a couple of times. The colors here on the screen, the brighter colors are areas where there's no vegetation. In many cases, just bare sand or rock. The Sahara Desert is very heterogeneous, meaning it's not a uniform cover of sand or sand dunes. There are volcanoes, there are jagged outcrops, there's a variety of dune fields, of course, and there's a lot of streakiness. We'll probably see some of that associated with the wind patterns that blow across the Sahara. So you'll see that there's a wonderful variety of patterns, and some of these you can see yourself at home on Google Earth. If you were to load Google Earth, it's a free program. You can download it, and you can follow our footsteps at home on Google Earth if you'd like to do that. And you'll see some of the same kinds of patterns, and you can explore some of them at greater length on your own. So this tour is really intended to give you sort of an introduction to some of the world's deserts. And here we're sort of in the central part of the Sahara. We're flying generally towards the east, and we're going to be ending up heading towards the Egypt and the eastern part of the Sahara. And I had first got introduced to the Sahara, but I was a student. I was working in East Africa, and then I came back to the United States via the Sudan, and I had an opportunity to take the train from Khartoum up to Wadi Halfa, which is the south end of Lake Nasser. And of course, being a student, I got the student discount ticket, and the student discount ticket was it gave me access to a very crowded car on this train, and there were some students there from Egypt, and they said, well, this is too tight. We can't stay in here. We have to go up onto the roof. And so I said, the roof? And they said, yeah, you just climb out this door here and you go up this little ladder and you're up on the roof. And the train was crossing what's there is called the Nubian Desert. It's part of the Sahara. And it was pretty nice to be up on the roof because there was a lot of room and it was easy. You could look around and pretty spectacular views. And we sat up there and it started to get dusk, and then it started to get dark. And we said, well, we're going to have to sleep up here. And they said, whatever you do, be sure you don't sleep lengthwise. You got to sleep crossways so that you don't roll off into the desert in the night. And then they said, because you're sleeping crossways, you got to be sure that your shoes stay on, because if your shoes fall off, they're never going to see those shoes again. And so I held my toes tight, and I was wrapped up in an Ethiopian blanket that I had, but it got really cold. And in that night, I didn't get very much sleep, partly because I was afraid of rolling off into the Nubian Desert, but also I was freezing to death. And so then I waited until dawn, and dawn sort of started to happen. And sort of like you can see here on the skyline, the sun rose into that hazy zone there. And I could see the sun, but I couldn't feel it. There was no warmth, and the sun was there and it was sort of in the haze and there was no warmth. And then the sun got up out of the haze and then we roasted. So we roasted our way across the Nubian Desert. And Chun, I think we can get ourselves over towards Egypt here, and you'll see we're sort of in central Sahara. We're probably in Libya, and there's some interesting volcanoes. There's a wide variety of dunes and dune fields, but we're going to go into the desert of Egypt, and you can see the land really is bright colored because there's highly reflective material. We call it it's called albedo. It's a very bright or high albedo, and then there's a dark little string there. And that's the river Nile, and it's actually the vegetation on the edges of the river Nile. And there's some wonderful stories about the agriculture along the Nile that we'll hint at here in a little bit. But I wanted to take you down to an oasis that's on the desert, near the oasis. This is called the Fayum Oasis. It's the little area straight up ahead. And astonishingly enough, if you get down on the ground here, we're going to zoom in a little bit closer to the ground. And the deserts are wonderful places for geologists because, of course, you can see the rocks really well. And you got to keep oriented so you don't get lost. There's a lot of places that look a lot alike in the desert. But, of course, with modern tools, it's easier to keep yourself located. But this is an area where there's wonderful fossils here in the Fayum area of Egypt. And one of the most impressive things, down in this rugged country that you're seeing Chun showing you here, there's all kinds of layered sedimentary rocks that have been sculpted by the wind, literally carved by the howling winds of the Sahara, and carrying sand and grit, eroding the rocks. And there's a pod of whales in here it's hard to believe, but there's Miocene whales that were in it when the ocean was a little bit deeper. This area was underwater, and these whales became stranded, maybe like that event in Tasmania here a couple of weeks ago. And if you go to the desert, this part of the Fayum area, I think we've got a photograph we can show sort of what they look like. They're literally lying there on the ground, and the wind has been blowing the sediments away from them. And this one's been enhanced a little bit by the paleontologists, but they've turned it into a national monument in Egypt. And you can visit the whales of the Fayum next time you guys when we get a chance to travel again and you go to Egypt. It's a little bit challenging to get out there. The taxi drivers in Cairo are a little bit reluctant to drive out into the desert. So you've got to find a brave taxi driver. But if you find a brave taxi driver in Cairo, they'll take you right out to see these whales lying stranded in the desert, and a wonderful sight. But we're going to continue our story here. We've got to keep on cruising along. We're going to look at the desert band that continues to the east. And I just want to point out some highlights. You can see some roads there just as we're backing out. Some of those are Jeep trails, and some of them are old caravan tracks, camel tracks. You can see them on Google Earth. We're going to cross across from Cairo here in the delta area of the Nile River. And I just wanted to highlight the Dead Sea area, just because it's one of the fun things that this is part of the desert system here, but this would be the lowest desert in the world, topographically lowest. And people always say, well, how low is low? And it's 1,300 feet below sea level, the Dead Sea. And it's interesting because the sea level of the Dead Sea is falling, sometimes up to a meter a year. So that number of how low is desert is always a little bit of a tricky number to come up with. And you've got to maybe even say the date at which the elevation was determined. But it is losing water in part because the water is being also used for irrigation and agriculture. We're going to continue our introduction to the deserts by crossing down across the Arabian Peninsula. We're going to see some beautiful patterns there. We'll be coming back to look at more closely some of these patterns, but we're going to be crossing the Empty Quarter, which is the sort of the southern part of the Arabian Peninsula. Famous Wilfred Thesiger wrote some books about traveling in the Empty Quarter. And Chun, I don't know if you want to zoom in, you might see some sand dunes if you zoom in somewhere in here, just to show the character of the land. It looks pretty bleak from a distance, but as you get closer to it, you'll see that it has wonderful textures, all kinds of amazing patterns. The dunes are starting to show up a little bit in the lower part of the screen. And there's just a vast array of different dunes sizes and shapes. And Thesiger wrote about it very beautifully in his writings. That's Wilfred Thesiger. A couple of other books on deserts while we're just admiring the desert here. There was a book my professor at Boulder, Julian Rasasco, mentioned to me called A Desert Calling by Michael Mayers. That's a book that if you want to follow up on deserts, you might be interested in. And there's a book that I read to our children when they were young as a bedtime story, which is The Cry of the Kalahari, another wonderful story about deserts. And both The Desert Calling and The Cry of the Kalahari, which is by Mark and Delia Owen, both of those books are sort of introductions to wildlife studies in the desert. And they are fascinating stories written by people very charismatically about, you know, being a student of the desert. So you might enjoy those. We're going to continue here. You can see the texture of the land. And again, if you do come into this territory on Google Earth, you'll see some of the same kinds of patterns. And you can scroll for a long time just looking at beautiful patterns on the desert caused by, in this case, the winds blowing the sands of the empty quarter. We're going to continue across, leaving the Persian Gulf. The deserts continue across Iraq and Iran, Persia here. We're crossing the bit of the Indian Ocean. The deserts continue up into Pakistan. It's called the Thar Desert, Thar, on either side of the Indus River. And then you'll see the Tibetan Plateau. And I want to emphasize that the Himalaya mountains form a fantastic rain shadow phenomenon because the moist air is coming up from the Indian subcontinent and it precipitates out as it hits the Himalayas. So you get a tremendous precipitation and snow phenomenon along the front, and then behind it, the ground is dry. So the Tibetan Plateau is dry. The Taklamakan Desert is up to the upper left in the Tarim Basin. And then as you come up to the upper right of the scene here, this would be the Gobi Desert. And we're looking at the terrain here that's in China for the most part. And this is territory that we'll talk about in more detail, but you can see the expanse of desert, the bright colors extending across much of what is really China and Mongolia. And then where most of the Chinese population, which is 1.4 billion people, more or less, they mostly live in the South China Plain, on the up closer to the coast. So the eastern side of China has the population. The western side of China is very dry, and the winds tend to blow from the west towards the east here. And one of the challenges that we'll talk about in a few minutes is how the Chinese are trying to control the desert because the wind is blowing dust and silt into their urban areas. And many of you know that Beijing has a big problem with air quality, and that's part of the story. We're going to now move across the Pacific Ocean relatively quickly, so hang on tight. And again, we're just trying to introduce a few more deserts, and we're skipping over Australia, which Chun and I both lamented a little bit, but in the interest of time, we're going to not show you the deserts of Australia, which are fabulous to see, but we're coming over here to the Atacama Desert, which several of you mentioned in the chat group you're curious about, and some of you have been there. That's an interesting place. And the Atacama Desert is located in the Andes Mountains of South America. It probably enjoys a little bit of Peru as well as Chile and Bolivia in terms of the countries involved. And it's a high desert and extremely dry. And I worked down in Bolivia, and I kept trying to figure out what was going on in terms of the precipitation patterns. And it was confusing to me initially, but I finally figured out that the wind patterns down here are blowing from the right-hand side to the left. So they're blowing from the east to the west. In the United States, we're used to the winds blowing from the west to the east, but down here it's the other way around, southern hemisphere. And consequently, there's a massive rain shadow on the eastern side of this picture in the middle. And you can see the green growing in Bolivia there. And then once the moisture-bearing air flows up and hits that mountain range, which is the Andes, it drops all its moisture. And then you get this great big dry zone on the backside of that. And coming off of the Pacific Ocean, It's relatively dry. There's strong cold currents moving there. Whatever moisture does come up is also caught as that tries to get across to the Atacama by the range of hills or mountains on the west side. So the Atacama is sort of the central trough area bounded by rain shadows and roughly at 30 degrees latitude. So it's got a variety of reasons for it to be super dry. And this is the Salar de Uyuni, one of the salt plains in the Atacama Desert. And there are weather stations down here that have never recorded any precipitation whatsoever. So it's considered to be the driest place on the planet. There's some places in Antarctica are vying for that title, but this is the little town of Uyuni with a super big airport there. Chun and I were speculating that maybe it was lengthened so that the shuttle could land on it if it had to, but we did lengthen a bunch of landing strips around the world to have places where the shuttle could land. In any case, you'll see the ground here is pretty bleak, but it's got a tremendous beauty to it. And I've seen lots of pictures. I've been on the edge of this, but I've not been out in the middle of it. But the photographs that I've seen are fabulous and very sort of eerie landscapes of ultra dry ground and salt deposits of all kinds scattered around as far as the eye can see. And there are roads, you can get there. I've seen, there's a lot of travel logs and discussions of this countryside, but you'll see it's extremely arid. So one of the great deserts of the world. And then as we wrap up our big tour of deserts, we're just going to nip up to the US and just point out Death Valley. And I just wanted to because many of you will have been there and know about it. So I just wanted to highlight one of our more desert-like places and put it into a similar context. It's a little bit, it's near the 30-degree north latitude, and it's also located just on the east side of the Sierras. So the ground in parts of Nevada and easternmost California are in a rain shadow on the east side of the Sierra Nevada mountains. And the Sierra Nevada, of course, means mountains with snow on them. So the snow lands on those mountains, and by the time you get to the east side of them, it is extremely dry. And Death Valley is, of course, a little bit below sea level. It's not as low as the Dead Sea. It's about 280 feet below sea level, Death Valley. But it's got the dubious honor of having recorded what they think is the hottest temperature recorded. And I think it was just in the last year, about 130 degrees Fahrenheit. And there's been some, if you read into it, you'll find that they're not sure if it's an official record. They want to make sure their thermometers were calibrated correctly and things like that. But 130 degrees Fahrenheit is a pretty ghastly thing. This is the Furnace Creek Valley comes in, and the Devil's Golf Course and places like that are right here in this view of Death Valley. So very accessible, and there's a wonderful national park here with a beautiful interpretive center. And if you do get a chance to travel out into this part of the world, I wouldn't necessarily go there in the middle of summer, but it is a fascinating environment to see, and it's extremely accessible, very easy to get there, and you can stay at Death Valley, or you can just visit from California or from Nevada. So I'd encourage you, this is one of the more extreme deserts in the world, but one that's very accessible to us who live here in the Western United States. We're going to now turn back to our touring of the world, and I'll ask you to bear with us because we're going to back out from the Western US here. You're seeing Nevada and the Rocky Mountains, the Great Lakes, and we're going to come back over to the Sahara Desert. And in this part of the talk, I'm now going to be emphasizing the things that people are doing in deserts. So we've seen some deserts on our first little loop here, and now we're going to revisit some of them and pay a little bit more attention to some of the activities that are going on where mankind is coping with living in these kinds of extreme environments. And we're going to come into the country of Senegal, which is here on the west coast of Africa. And the transition zone between the vegetated area to the south and the Sahara Desert is called the Sahel. And that's the name for this broad zone of sort of transition. And it's a zone where, there's occasional rainfall, and then there's occasional dry times, and it sort of fluctuates a little bit. And people have been coping with this in part by being nomadic. So there's a lifestyle in this part of the world where people will move their herds and themselves to follow the rain. But the people who are living in a more sedentary way, the people that are trying to practice agriculture, are learning that you can live in these areas, and you've got to be careful about how you irrigate and how you use the water that's available, and also the way in which you control the grazing of the animals that are in some cases sort of wandering pretty freely. And one of course, the ways to control the grazing patterns is to put in fencing. And there's a program that's called the Great Green Wall, and it's a wonderful concept of putting a green wall through the Sahel area of the southern Sahara to serve as a buffer between the desert to the north and the greener ground to the south. And the Great Green Wall isn't really a fence or a specific set of fences. It's really more a philosophy, and it spans over 5,000 miles from the west side of Africa to the east side. And here you're seeing a piece of it. This is a forest preserve in Senegal, and you can recognize by the color, and especially the sharp lines, you can appreciate that there's a fenced in area there. And there's a series of these, they call them forest preserves in Senegal, and they're controlling the way in which animals graze on the ground within the forest preserves. And they're doing it by building fences and fencing off certain areas. And you can see it, from space, as it were. And these areas of preserved ground are gradually getting bigger, and in places they're planting trees. There's been a lot of controversy about whether the trees really survive or not in some of this Sahel area, but people are trying to plant trees. There are programs for tree planting, and there are 20 countries involved, and it's a program that was put together by the African Union starting back in about 2007. So it's only been going for a relatively short amount of time. But as we sort of spool across the southern Sahara here, and again, I'd invite you to experiment yourselves, you'll see a wide variety of different strategies where some of them are big, some of them are small, but fenced in enclosures. You'll even recognize places where trees have been planted. And there is an effort here communally to put a barrier between the Sahara to the north and the vegetated area, which really is the Congo Basin down there to the south. And you'll see that there's the Lake Chad has a little bit of water in it from time to time. It fluctuates. So there are, Lake Chad's just coming in there on the right-hand side of the screen. And there are, people who are out here living, and they're challenged by the landscape. And in many cases, they're tempted to migrate away. You've heard of people moving across the Sahara, perhaps coming up into Europe. And if we can encourage them to find ways to make the desert more survivable, to figure out ways to bring in agriculture, it might be that they could make a living without needing to migrate up into Europe. And so we're going to follow that up here as we come up back towards the Nile River. And I've looked at the irrigation practices along the Nile, and there's wonderful examples of people who are putting in innovative drip systems adjacent to the Nile River, trying to literally farm in the Sahara. And I've seen it working on the fringes of the Nile in Egypt. But we're going to go across to the Negev Desert. We're going to cross the Gulf of Suez here and cross the Sinai Peninsula, and we're going to come up in towards that area on the south side of the southwest side of the Dead Sea. And this is it's called the Negev Desert. It's pretty dry here, but there's been a tremendous amount of technology applied, and in this region, of course, water shortages are extreme. I mean, we have nothing to compare. In this part of the world, every drop of water is extraordinarily precious, and it's reused again and again. And in this part of the world, the water that's been used in urban areas has been recycled again and again, and eventually it gets to a point where it's not drinkable anymore, but it can still be used for agriculture. And you'll see some plots here, And there's a variety of strategies, but these settlements here in the Negev Desert are places where extremely innovative people are developing strategies for growing crops in the desert. And I visited it a few years ago, and I went to one of these pots, and you can see this is an image of one of the greenhouses, and it's a plastic greenhouse, plastic top, plastic bottom, with plants growing inside, and the drip system goes right to the roots of those plants. And I think if you go inside the greenhouse, the next picture shows what you see. There's melons hanging from the ceiling. I mean, it's astonishing. You walk into the thing and you hit your head on a melon. And these are grown in a landscape where it hardly ever rains. But if you can, tend the conditions properly, you can use what available water you might have. They put the fertilizer right in the water. They call it fertigation. And they're growing melons, they're growing peppers, they're growing tomatoes. And it's a fabulous example of human ingenuity growing crops in the desert. We're going to scoot down a little bit and see a couple more examples in this area. A few years ago, I was traveling in Jordan with my son, and we were visiting areas, and we looked at the satellite images, and we found this mysterious feature that we could see on Google Earth, and we had no idea what it was. And we literally rented a car and drove out to look at it, among other places. There's fabulous things to see in Jordan. If you get a chance to travel in this part of the world, you're near the famous rose city of Petra. You're also near Wadi Rum, which is a fabulous place to see, astonishing landscapes. But one of the things that we were curious about was this feature that we could see from space, and we'll see it as we're homing in on it here. And it turns out that there's this magical terraforming going on where they're literally transforming the world. And it's a very curious shape. You'll see it's sort of a top hat shaped, or a witch's hat shaped feature right there in the middle of the screen. We're going to zoom in on it. And it's this magnificent array of little ponds and planted trees. And it's a true astonishing oasis in the middle of the desert. It's completely man-made. And it turns out that the prince from Dubai, Mohammed Al Maktoum, actually the leader of Dubai, married the princess from Jordan, the half-sister of Jordan's King Abdullah, Princess Haya. And as part of the marriage arrangements, he built her this fabulous spot, and they're using groundwater, which they're pumping out of the aquifers here. But there's a palace up on top of a hill, and then there's this tremendous array, and it turns out that ducks land here, and hard to believe, but there's actually a duck hunting situation. A limited number of the ducks that pass through here are hunted as sport, and the ducks land on these ponds and see the greenery, and there's a hunting preserve there, and it's papyrus is growing there, and my son and I, we walked up on the cliffs there on the left-hand side of the screen, and we couldn't really get inside. There's a big fence around this whole place, you can well imagine, but we saw it and admired it, and we watched the people who were trimming the papyrus plants on the edges of those ponds in the middle of this amazing desert. So water is a magic thing, and if you've got water, you can do amazing things. And this part of the world has groundwater, and there's a project to bring the groundwater up to Amman, the capital of Jordan. And there's always a question about how much groundwater is there, and you'll start to see some center pivots here, those round things. But we're going to nip over into Saudi Arabia. We'll cross the border here and just go a little bit to the east and show you the potential for irrigating the desert using groundwater. And it's a tremendous phenomenon. And here we're in Saudi Arabia now, we crossed the border. And this green stuff that you're starting to see here on the screen is each one of those things is a center pivot, which many of you are familiar with. We use the same technology here in Colorado and on the high plains in Kansas and Nebraska, where they're often using the Ogallala aquifer. And each one of these center pivots would have access to a well and a pipe, and there'd be a central sprinkler system that runs around. And this has literally come out of the desert in just the last few years. And Google Earth has a timeline phenomenon on it. You can see here, this is in 1990, what it looked like. And then if we go forward, the year 2016, so 26 years later, you had this complete transformation of the land. And it's a testimony, of course, to a lot of hard work to make this happen. A lot of people working there, but it's also a question about, how sustainable is the water use? And one of the things that has been discussed in the literature, and I've read bits and pieces about it, is that some of the water tables in these areas are falling. It's not quite sure if the water supply is secure. And Saudi Arabia has a lot of potential. They've got a lot of energy. And in some cases, they can desalinate water to provide irrigation water, but it gets pretty expensive. And there are questions about, well, how much food can they grow in Saudi Arabia using this technology, and how sustainable is it? And it's a dynamic question. It's being asked today, but you can see that the Saudi people are trying to make use of their desert for agriculture, as are the people in Jordan, on the West Bank, in Israel, in Egypt, throughout the region. People are making a very small amount of water go a long way, and using drip systems and innovative irrigation technologies to allow them to grow food in the desert. We're going to nip across to ground that we've been in before. We're crossing India, crossing Tibet, and we're going to be coming up to China and the Gobi Desert. And I'm just going to highlight that there's another wall here in China. They call it the Great Wall of Solar. And in the western deserts of China, there's a tremendous innovation going on, putting solar panels in ground that's flat, and of course very beautiful sunlight resources. And the Chinese have built some of the largest solar facilities on Earth. In fact, they are the largest solar facilities on Earth. They're many tens of square kilometers in size, and they have millions of solar panels. I mean, the one that we're going to look at here in the Gobi is Longyangxia, and it's got 4 million solar panels, and it's linked up to a hydroelectric project in the reservoir just to the east of it. But you'll start to see the desert take on an interesting pattern here as we get in a little bit closer, and it tiles in. And again, you can look on Google Earth, you'll see this thing, pops in very quickly. The Chinese are very industrious people, and of course, they're producing a massive amount of these solar panels. So here in 2012, it was a little tiny bit, and then as the years went by, you'll see that they spread out across the desert to the point where by the time you get to 2016, they're covering a vast area. And I think we've got the city of Denver at the same scale. We might, maybe the next name there. So there's the city of Denver, a little bit blurry, but you've got Wheat Ridge on the left, and you've got Aurora out there on the right. The airport's just off the scene on the upper right. So that is the same scale. So it covers the entire Metro Denver area in terms of real estate in solar panels. So these are phenomenal things. And this is just one of many of them that are out there in the deserts of China. And I think maybe, Kachin, if we go over to the eastern Gobi, we'll get a look at a strange shape solar panel system. Let's see if we can see that. And we're going to be looking at the area that's relatively closer to Beijing. Now we're coming into the eastern Gobi Desert. We'll drop down in there and look at the solar panels that they're building in this part of the world. And again, they're capturing energy from the desert and they're moving it to their cities. And it's part of a tremendous ongoing project to develop solar energy in the deserts. Something that the Chinese people are doing with very impressive scale, and something that we'll show some other examples around the world as we go. But you'll see this more and more where you have flat ground in brightly lit areas. It will invite photovoltaics, and we do that a lot, of course, here in Colorado. But as we zoom in here, we're going to see a strange shape, I think, coming in just a little bit to the right of center, and we'll invite you guys to see if you see something interesting in the shape of the photovoltaic panels. So stand by for a view of interesting photovoltaics. And we're just sort of dropping down onto this landscape, and the computer is sort of catching up and buffering in the images. So it's yeah, just to the right of center there. I can see some landmarks coming in. As you look at China, and you might do it on Google Earth, you'll quickly recognize a remarkable energy and effort going into terraforming, and between irrigation systems and photovoltaics, there's a huge amount of activity going on in these deserts to the west of Beijing. Now we're coming down in, and I'm inviting you to look at the photovoltaic patterns here and see if there's something that you might recognize. I'm looking at the chat to see if people are identifying these features, and the chat, yes, the chat's going wild. Judy's figured it out. She spotted it. So, and there, Sandy's seen it too. You guys, what do you see there? Waving at you. Yeah, so Mark's seeing it. Yeah, Martha's seeing it. The Panda Bears of China are waving at you. Heather's seeing it. Mary's seeing it. People are seeing the Panda Bears. There's 2 pandas down there waving at you. And you'd have to, of course, be in an airplane to see them. You wouldn't be able to see these from the ground. But they're wonderful little critters there. Of course, China's national symbol. They're waving at you. So the landscape here is really being modulated by people. And I'm going to sort of, as we draw to a close, I'm going to show you a couple more examples in China, and then we're going to scoot back over to the US. But if we could go over to the Tadpole Mountain here, Chun, and I call it Tadpole Mountain because it sort of looks like a tadpole. And it has, I'm sure, a very nice name, but just for our purposes of finding it, I think it's maybe still to the left. Oh, there, maybe it's, oh, there it is, right center bottom, yep. And this is a feature that I've just looked at it on satellite images. I've not been here yet. I hope to get here someday, but it struck me as a very strange pattern. And we've zoomed in close, and you'll see that it's obviously darker around the fringes of this mountain. And then the more closely you look at it, the more you realize that this dark fringe pattern is very tightly controlled by what has to be a fence. So this is a forest preserve or a nature preserve, and they're just basically controlling the grazing pattern. So outside the fence, you'd have heavier grazing, and inside the fence, you'd have controlled grazing, and it's allowing the vegetation to come back, and it's changing the character of the land. The other thing the Chinese people are doing, which is astonishing, is they take actually active sand dune areas, and they'll put in grids of straw. They put the straw on the ground, and they put a shovel to it, and they make a little grid pattern that's about 1 meter on a side, too small to be seen from our space systems. But there's other places in China where you'll see patterns that are not natural, meaning that man is down there working with the desert, controlling the desert, and modifying the extent of the desert. And of course, in this part of the world, again, the wind is blowing from the west to the east. And so the people in Beijing and the populated South China Basin are keenly interested in reducing the amount of sand, we call it wind-blown silt or loess. And so the stabilization of the desert in this part of the world is an economic priority. And a tremendous amount of work is going on in China to stabilize the desert, astonishing amounts of labor going into that effort. But now, as we draw to a close, we'll come back to the United States, and I want to take us to the sand dunes of Nebraska. And many of you will have seen the sand hills or know about the sand hills in Nebraska. And that's a place where the desert has been naturally stabilized. And it's a really astonishing phenomenon once you see it. And you can see some of this when you fly out of Denver, when we next fly again. If you fly out of DIA at low sun angle, if you fly east, you'll look out the window and you'll see sand dunes that are basically stabilized by prairie grasses. And we're going to drop down here into Nebraska, central Nebraska. And this is a place, we're going to be next to a town called Halsey. And back in the early 1900s, the beginning of the 1900s, a fellow named Charles Bessey had the idea of trying to modify the land. And I was flying from Frankfurt to Denver, and I was actually sitting on a central middle seat, and I was leaning over my companions, as is customary, to try to gaze out the window. And I saw this astonishing thing out the window of the airplane, and I figured I had to be somewhere in Nebraska. And then I looked for it on Google Earth, and I found this feature that we're coming into now. And you'll see the surrounding countryside is sand dunes. You'll recognize as it focuses, you'll see the shape of the dunes, and they're stabilized by grass. It's a wonderful place for cattle. But this feature that you're seeing here that's going to come a little bit more crisp is a 30 square mile forest. And this guy, Charles Bessey, back in 1902, had the idea that maybe he could grow trees in Nebraska. And when they start out, of course, you've got to take care of them and water them carefully. But eventually the trees take hold. And these are mostly pine trees. There's a variety of different species. But this is a place, it's the largest man-made forest in the United States. And it's in central Nebraska. And you can see it's a little bit erratic. They've had some fires that have burned parts of it, and parts of it have died out, and other parts are growing. But in aggregate, there's 30 square miles of trees in the middle of the sandhills of Nebraska, and it's entirely a man-made phenomenon. But what it shows, certainly to me, is it shows that the trees can live there, and in the right circumstances, there's no reason why we couldn't have more of a forest in Nebraska. I talk to the people here on the phone, and they say, oh my gosh, the local people think the trees are escaping. The local people love the grasslands, and they're worried about the invasive trees that are coming across from the edges of this forest. But the day might come when we grow more trees in Nebraska, so we can do things like that. But we'll look at let's look at two more examples here in the US. We'll go quickly over to the Mojave Desert, and I'm just going to take you down to the Imperial Valley in southernmost California, right on the Mexican border. And just some of you are familiar with the Salton Sea. This is the north end of the Gulf of California, and the border between the US and Mexico is very distinct in here because of the change in land use patterns. But in the United States, we're running out of water, as you've heard. And as it gets drier with warmer conditions, there'll be more pressure on water, and we'll be moving water away from agriculture to the people in the cities who want the water. And the water, we have this expression, the water flows uphill towards money. So some of these areas that today are irrigated are going to be less irrigated in the future because the water will become more valuable. And here, right on the Mexican border, the southwestern edge of the Imperial Valley, look at what's happening to the fields. And these fields were all growing crops just a few years ago. 10 or 15 years ago, these fields were growing crops. And now I think you'll recognize, even though we haven't had the imagination to put a panda bear in there, but you'll see these are solar panels that are growing in these fields, replacing the plants that used to be there. And now just to bring it home, why don't we're going to scoot back over to Colorado, and we'll take 1 or 2 minutes just to look at something in Colorado. But think of some questions. If you have questions, you can type them into the chat, and Selena will help us organize questions. So, but we're going to come in here. This is the San Luis Valley in Colorado, and many of you will have been here. The Great Sand Dunes are starting to show up, and we might fly in via the Great Sand Dunes, Chun, just so we can see the dunes. And that's a little mini desert right here in Colorado. Certainly by any standard, when you're standing amongst those dunes, you're in a desert. And there's some of the largest sand dunes in the Western US, and they're very beautiful and very accessible. It's only a few hours away from Denver. And there's a national monument here. You can visit the Great Sand Dunes National Monument and walk among these dunes. And people snowboard on them. They take their old snowboards and they snowboard down those dunes. It's astonishing. But right near these dunes, just on the other side of the alligator farm, there's something interesting to look at, and we're going to scoot over there for our last view. And I'm going to, again, mimic some of the patterns we've seen in other parts of the world and say, well, here we're going to come into a Colorado context, and we're seeing some of the same phenomenon that we've seen in other places in the world. And these are center pivots. They're growing mostly potatoes in this part of the San Luis Basin, and there's a water shortage because we're using groundwater in most cases here. and we're obligated to send groundwater to New Mexico so that they can use it for drinking. And so we've got a water shortage in the San Luis Valley of Colorado. And you can see in this area, there are fields that used to be growing potatoes. And in fact, on Google Earth, you can look back and you'll see that just recently there were potatoes here. And today, as you zoom in, you'll see that there's something very different than potatoes there. And I took a group here from the Colorado School of Mines a few years ago, and we were approaching, and we had the students all wearing orange vests so they don't get squashed on the street. And we showed up at the gate, and I couldn't telephone ahead of time. I couldn't find the number. We show up at the gate of this place, right? The gate's right at the top, right there. And we got like 35 students wearing orange vests. And the guy comes out and he greets us with a great big grin. And I said, oh my gosh, he's super hospitable. And he let us in the gate. And he thought that we were the work crew from the state penitentiary coming to trim the weeds. But we were really a bunch of School of Mines kids wanting to see the facility. And it was extraordinarily interesting. He gave us a tour. They had different kinds of photovoltaics. Some of them were pivoting and swiveling, and some in one dimension, some in two. And he ran the whole place with he had one of those Zerk guns, you know, for putting grease in the things. And he said with a screwdriver and his grease gun, he could run the whole place. And this is relatively small by Chinese standards. It's only about 8 acres. It's about a 8 megawatt project. The Chinese ones are 800 megawatts, so 2 orders of magnitude bigger than this. But the potential for us to do the same thing that's happening in China is, of course, here. And to sort of finish up our presentation, and before we shift over to questions, I'm just going to loop with this concept that the deserts of the world, which are going to get bigger and they are going to get hotter. I'm answering a question there in the chat about whether the deserts are getting bigger. All the deserts of the world are likely to get larger, and probably the Sahara being the largest is one of the ones that's growing the biggest. But we have the ability with our technology to not only use the desert as a resource for generating electricity through photovoltaics, but also in places where it's appropriate and practical, we can go in and develop agriculture, we can develop farming practices, produce food, stabilize the ground, and to some degree limit the expanse and growth of the desert. So I'd like to leave that as sort of the final thought, and recognizing that climate is changing, the patterns of the earth is changing, but the people are innovative and people are sharing information across the world and sharing technology. And some people are building walls. They're not fences against people, but they're walls of green, or they're walls of photovoltaic. And we are in a time of technology that's a wonderful place, offering many opportunities for young people to get out there and find new careers in making the deserts of the world productive and lifestyles around them more sustainable. So with that, Celine, we might turn it over to questions if people have questions, and just take a few more minutes. It's about 8 o'clock, but if we take maybe 8 or 10 minutes for some Q&A, we could do that.
Oh, and just a reminder that Celine has put the link to the survey. And so if you can, please take the survey and let us know about what you think about this program.
And Chun, remind me, so it's the first 30 people get some NASA swag. What exactly is it?
It's a NASA logo sticker. So it's not amazing swag, but it's pretty good if you're a big fan of NASA.
I think you underestimate how much millennials love our stickers. Wonderful. Well, thank you all so much. I definitely learned a lot through that, going around the world twice. I don't think I've ever done it once, so thank you for that experience. I think, thinking of your last statement, Bob, one of the questions that we got was about this idea of the survivability in deserts. So you mentioned different ways that folks are making, growing out agriculture in the deserts. With other folks are also using the desert space for things like solar panels. Can you talk about a little bit about the technology and what hope we see in the future?
No, absolutely. So for example, the irrigation technology, which I saw in the Negev Desert, is there's an outfit called Netafim over there, which is producing drip systems, and they're being widely used. I've seen them being used in Egypt, and then I was in Weld County a few years ago, which is near Greeley. And the people in that area had their water wells shut down because there was they were taking water out of the gravels of the South Platte River, and they were thinking that it was deep groundwater, and it was really essentially river water. And there was a time when the state engineer's office was closing in those wells, and the people had the fields all set up and organized, and they were bringing in the same drip system that I saw being used in Egypt. They were bringing it over to Weld County. And fascinating story. They put the drip pipes in, and they're very expensive, and it's very, valuable. And they put them in at about 8 to 10 inches deep. And then they're driving their tractors around, and the guy says, well, we have our furrowing system, and we furrow down to like 5 inches. And I said, how can you furrow down to 5 inches when you've got drip system buried only at 6 or 8 inches underneath it? And he says, well, we have GPS on our tractors. And I said, well, I know a little bit about GPS, and GPS is very good for north and south, east and west, but it's not very good for up and down. But he said, we've got a trick. He says, we've put a base station up on our silo, and the base station is talking to the satellites and talking to the tractor, and that tractor knows where it is within millimeters. So it's a super use of technology to allow the tractor to move around. And he said, if anything goes wrong with the GPS system, the tractors all stop because they don't want to screw up the drip systems that are buried in the ground. And that technology, where you put the water right where the roots are, that's a fantastic way of using water very efficiently.
That is wonderful. And on that note of the really cool technology, Chun, you got to literally guide us around the world a few different times. Can you, and your background is definitely space, can you tell us a little bit about the role of the technology that is helping us track these changes, like how we're able to literally be in our homes and travel across the world and be able to see changes that are happening in our deserts?
Yeah, so a lot of it is the fact that we have a lot of satellites that are up in orbit. And many of you have heard of Moore's Law, where our computing capacity is increasing exponentially over time, although there are some hints that it's slowing down. But similarly, the amount of data that we're getting from satellites that are actually pointed down at the Earth instead of pointed back out into space, that has been increasing by quite a bit as well. It's definitely increasing faster than linearly. And so all these satellites are providing information about our planet Earth. Not only are there weather satellites, but there are satellites that periodically map the Earth. They are looking, like Landsat satellites, they look at different wavelengths where we can determine information like vegetation percentages, things like that. And so there's an enormous amount of, almost like a fire hose of information, and tools like OpenSpace are being developed as a way for us to process all this data. And so NASA feels it's important to sponsor these sort of things, not only for the science that can be done, but also as a way for educating the public, just because of so much data that is becoming available.
The symbiosis of from space to Earth and Earth to space. That's beautiful. So one of the things that we got in the chat quite a bit, Bob, is apparently we would all like to travel with you. Can you tell us a little bit more about how it is that you're able to explore things without actually going, and what the difference is between exploring on Google Earth and then deciding that you're going to visit this unique place in Jordan?
Yeah, right. And I saw a couple of questions about specific things about like when to visit various places. And so, for example, Death Valley is a place that's pretty easy to get to, in the sense that you can drive there, of course. From here, you'd have to spend a night maybe on the way. And even in these conditions, you could find a camping spot somewhere in western Utah, for example, and then you could probably get to Death Valley in a couple of days, certainly 3 days. And I would go not in the middle of the summer, but right around now would be a good time to go there. And to answer your other part of the question there, Celine, I'm a geologist, and as a geologist, we study the Earth, and I've had the opportunity to travel in many different deserts, partly because the rock exposures are really good in deserts. So we've done field trips in Nevada, for example, from Denver. We run field trips out there. Many field trips go to westernmost Colorado. We call it the Great American Desert, and there's a precipitation pattern. If you look at rainfall patterns in the United States, the western part of the United States is relatively arid. And so there are lots of dry areas. And in those areas, the geology is particularly well. You know, Chun has it behind him right now. You can see how there's a middle stripe there in North America, where west of about 100 degrees of longitude, it's pretty dry, and you need to irrigate crops. So west of that line, east of that line, you can grow it from rainfall. But the traveling is something where, in some cases, I've actually deliberately looked at Google Earth beforehand and then gone to a place. That's how we found that duck place in Jordan. But other times, you know, you just go and see what you see. And I certainly encourage all of you to travel. It's certainly, you know, these times are difficult, but travel is, you know, it might not be international travel, but local travel is possible. And if you're, you know, appropriately careful, maintaining distance, wearing masks, things of that sort, there's no reason why you couldn't go over and look at the sand dunes, for example, in the San Luis Valley. I'd encourage people in Denver to take a look. It's in your backyard, and if you go over there, you can do that in a day trip from Denver. You're outside. It's as safe as it can be, and I would encourage viewers to see these things for themselves. There's no substitute to seeing it yourself. I mean, honestly, that memory of seeing something and the texture and the feel of it is, you can't replace that with any virtual reality that we know of yet right now.
Well, Bob, I'm sorry, but my next question is that we're going to try. Could you let us know what the locations that we traveled to virtually were today for folks that want to explore it on their own for Google Earth? So we had a question about the pandas, because the pandas are always popular, call it pandemonium, or sorry, I'm giggling at my own joke. And then we had another question about the location of the whales.
So the whales are located next to the Fayum Depression in Egypt. And Fayum is spelled like F-A-Y-O-U-M. And if you were to Google Fayum and whales, you'll find a lot of information about those whales. And there's some, yeah, it's spelled out, Chun spelled it. It's not quite clear to me that you can actually see there's a little whale museum and there's a whale visitor center and stuff. I don't know if you can really see that on Google Earth. I couldn't really see it, but you can definitely see the area. And then the panda bears, that's a little trickier. It took me a while to find them. I learned that they were there, I think probably from an image on Google somewhere, but then I was out prospecting for them. And they're near a place called Datong, I think it is, in China.
Yeah, I posted the name on.
Yeah, D-A-T-O-N-G. And if you Google Datong, or if you go there on Google Earth, it'll get you close. But those pandas are a little bit hard to find, and I would challenge the viewers to go panda hunting, because you can get yourself close, and then you've got to, you know, poke around and find them. They're there.
Well, we have a few folks in the chat saying that the challenge is accepted. So maybe if you all find the pandas, take a screenshot of it, and on your social media, hashtag DMNS Science Party. That's our fun museum hashtag right now. Awesome. Well, I think that's about all the time for questions that we have. I will ask you both, is there any parting wisdom that you would like to give our today's attendees? Bob, we can start with you.
Well, I would just encourage people to, you know, explore the world. I mean, it's your world. We all live here. And especially if you can get young people out, you know, if you've got children or grandchildren, if you can give them the opportunity to travel, even locally, and just see things on their own, they're marvelously curious. And you can go to Dinosaur Ridge, you can go to some of the parks right around Denver, and you can see a lot of wonderful things right in our own backyard. And that's one of the wonderful things about living in Colorado. But even if you're anywhere on Earth, I always say to anybody, I say, you just step outside the door and there's something there to see regardless of where you're living. So I would just encourage people to get outside and explore.
Yeah, and as a complement to that, there's also a huge amount that you can do to explore our world virtually as well. And NASA Earth Observatory has a lot of great images of our Earth from space. And we also provide a lot of images of how our Earth has changed over time. You can see the impacts from humans and from natural disasters, hurricanes, storms, things like that. So definitely check out a lot of great NASA resources that are out there.
Well, thank you both so much for taking us on this tour around the world. Thank you to everybody for continuing to support our DMNS programming. We are so grateful to have you from the comfort of your own home, your friend's house, your couch. If you're a passenger in the car who's streaming us, thank you all so much. We will see you all next time.